So here's an example of a more difficult factoring problem. You begin with this problem here, factor 6x to the fourth plus 9x cubed minus 54x squared minus 81x. And remember your factoring procedure, the first thing you should be looking for is the greatest common monomial factor. So the biggest thing that's going to go into all of these things here, 6, 9, 54, 81, it looks like a 3 goes into all of those. I'll be taking a 3 out. And then also remember to look at your x's. If there are x's in all of these, x to the first is the smallest power. That's the one that's going to go into all of these. So x comes out. So 3x times 2x to the third, that gives you the 6x to the fourth. 3x times a 3x squared will give you 9x to the third. 3 times a negative 18x will give you 54x to the second. And then 3 times a negative 27 will give you the negative 81x. So we've factored out the greatest monomial factor. Remember that you usually want to look inside here and make sure there's nothing else that can go into all of these numbers here and that there are no extra x's that go into all of these here. So this is now completely factored out with the monomial factor. Next, remember we count the number of terms. There are 4 terms here, and when there are 4 terms, we just go to factoring by grouping. So we factor the greatest common factor out of the first 2, which appears to be x to the second. So you get x squared times 2x plus 3. And then the greatest factor coming out of these 2 will be a 9. Remember, if there's a negative in front of the third term, pull a negative 9 out. So you're going to get a positive 2x plus 3, because negative 9 times a positive 3 makes the negative 27. So the 2x plus 3 is common in both. That is one of your factors, 2x plus 3. Don't lose this 3x. That was also part of your factor. And then x squared minus 9 is left over. Once you get here, remember to look inside the parentheses and see if anything else can be factored. Hopefully you recognize that x squared minus 9 is a difference of perfect squares. So that can be factored into an x plus 3 times an x minus 3. You still have the 2x plus 3 as one of your factors, and you have the 3x. So this is now completely factored. If you multiplied everything here together, you should get back what you started with.